A little under a year ago, I reviewed the Elegoo Centauri Carbon, a fully enclosed corexy 3D printer that proved itself to be quite capable while carrying a surprisingly competitive price tag. While I did have some gripes with it, like thermal drift that occurred when I printed with higher temp filament, it handled most of what I threw at it. Since then, a large community has formed around it, releasing quality of life improvements in the form of printable upgrades as well as a custom firmware. Towards the end of last year, Elegoo reached out letting me know they were releasing a new printer in the Centauri line, the Elegoo Centauri Carbon 2, and asked if I was interested in testing it out. I try to cover a wide range of machines on this channel, and given my largely positive experience with the Elegoo Centauri Carbon 1, I was curious to see what their second take at a Core XY 3D printer looked like, and I agreed to take a look. In this video, we'll dive into the Centauri Carbon 2. We'll go over its specs, what the setup process is like, how it's performed, and I'll give you my overall thoughts based on my time with it so far. So with all that being said, and without further ado, let's get right into today's video. The Centauri Carbon 2 is a fully enclosed Core XY 3D printer with a build volume of 256mm in X, Y, and Z. For motion, the X and Y axis use linear rods and bearings, and the bed or the Z axis rides up and down using 3 linear rods and 3 lead screws. Structurally, the machine is very similar to the original Centauri Carbon. The printer is largely made up of steel panels and uses plenty of injection molded parts throughout. It still features the same glass front door, but instead of the top glass panel, they've replaced it with a large plastic hood. This is necessary to route the 4 Bowden cables going from the Elegoo Canvas, their multicolor add-on, to the toolhead of this printer. And as of right now, and as far as I can tell, the combo with the printer and multicolor canvas is the only configuration it's available in. We'll take a closer look at this system shortly. The toolhead on this printer will look really familiar to the one of the previous generation, but there are a few differences. Pulling the front cover of the toolhead forward and lifting it off of its tabs will give us a peek underneath. The only real difference I noticed right away was that there was a new PCB mounted to the front of the extruder, as well as a few additional wires going down to what looks like maybe a smaller PCB on top of the Hotend cooling fan shroud. I'm not entirely sure what all of the new electronics are for in the toolhead, but I did confirm in my testing through a print running out of filament that there is now a filament runout sensor built into the toolhead, unlike the Centauri Carbon 1 that used an external runout sensor. The extruder itself appears to be identical, and the Hotend physically also looks the exact same as the one on the Carbon 1. The Centauri Carbon 2 advertises a max temperature of 350 Celsius, which is a bump over the previous machine which capped out at 320 Celsius. Since I recently finished installing the MicroSwiss FlowTech Hotend on the Elegoo Centauri Carbon, I reached out to MicroSwiss to see if they knew of any differences in the Hotend between that printer and this one. They confirmed my speculation that the Hotend physically between the two printers is the exact same. However, the Centauri Carbon 2's is using a different thermistor. For anyone interested, MicroSwiss let me know they are working on and will be releasing soon a drop-in replacement Hotend for the Centauri Carbon 2. Outside of this, the filament cutter is identical to the previous one, but they are using a brand new layer cooling fan behind the front cover, as well as an updated cooling shroud. In addition to the toolhead cooling, there is a new large auxiliary fan on the left side of the printer that's used to blow air across the build plate. Today's video is brought to you by MicroSwiss. Based in the US, MicroSwiss manufactures high-quality 3D printer upgrades, including extruders, hot ends, and nozzles for over 150 different models. I've been running their hardware in my machines for over 6 years, and have always been impressed by their meticulous attention to detail. Their newest line of drop-in hot ends called FlowTech features high flow, and its leak-proof design allows for cold nozzle swapping. FlowTech is constantly expanding, and they recently added a version for the Bamboo Lab X1 and P1 series of printers. From plated brass and hardened steel CM2 to CHT and Diamondback, they have nozzles available for any application. Links are in the description to find out more about the various upgrades they offer or to pick up your own. Moving on to the rest of the internals, the included build plate uses a magnetic flex plate system, and it ships with a dual-sided powder-coated PEI sheet. One side, labeled as side A, is sort of your typical rough texture PEI, and the other side, labeled as side B, which notates it's intended for PLA printing, still has some texture, but it's a lot less aggressive. The printer uses automatic bed leveling and appears to use the same setup as the Carbon 1, which has a load cell in each of the 4 corners of the bed. The images on the product page make it look like there's also some sort of a sensor or load cell inside the toolhead, but based off of the electronics I saw when opening that front cover, I'm not convinced that's actually the case. Towards the back right of the printer is a removable grill that houses the carbon filter. This got an upgrade, and the media inside of it looks like it's approximately double of what comes inside of the Carbon 1. Back there are also automated vents that are supposed to open when printing with materials like PLA to prevent heat creep, and close when printing with materials like ABS to keep heat inside. In theory, I like this idea a lot. However, it looks like the implementation is sort of half-baked, and even when the vents are closed, if I remove that carbon filter, you can see that there is a large gap that allows for air exchange outside of the printer. At the back left, we have the nozzle wiping area as well as the purge chute. There's a rubber-like brush to scrub and park the nozzle, as well as a latch that's used to scrape any purged filament and open the chute so that way filament that has been purged can eject out the back of the machine. A few other things worth pointing out inside the printer is a camera at the front right for monitoring your prints, as well as 2 sets of LEDs. One is on the right panel and one is inside of the front door. In my review of the Carbon 1, one of my complaints was just how dark the inside of the chamber was, which made it pretty difficult to monitor prints without any sort of additional lighting. While the lighting in the Carbon 2 still isn't fantastic, I have to give credit where credit's due, and it's a definite improvement. Interfacing with this machine is done using the 5-inch touchscreen located at the front bottom right of the printer. This is an upgrade from the 4.3-inch touchscreen on the Carbon 1, and one that I've really enjoyed using. While I didn't have any real complaints with the 4.3-inch version, I find the slightly larger menu options a bit easier to navigate, and I'm also using the screen more often with this printer to do things like assign the filament type and color loaded. On the right side of the machine are 4 spool holders used to hold all of your filament that loads into the canvas system. These are really similar to what we've seen on the AMS Lite as well as the AD5X printer I reviewed earlier this year, and overall I don't have a whole lot of complaints about them, and they seem to work with a wide range of inner spool filament diameters. During my testing I used roughly 5 or 6 different filament spools from various manufacturers, and there was only one in particular that the inner diameter was just too large for it to fit snugly on one of those holders. This is probably a good time to talk about the biggest difference between the Carbon 1 and the Carbon 2, which is multicolor printing. The Centauri Carbon 2 is capable of printing with 4 colors in the same print using a system that Elegoo is calling Canvas. Canvas is essentially a hub where filament is loaded into one of 4 different lanes. It handles both feeding and retracting filament from that hub all the way to and from the toolhead. Each lane has its own drive gears as well as a sensor to detect whether filament is present. On the other end, there are 4 Bowden tubes coming out of Canvas that attach to a connector at the top of the toolhead. This allows filament to be staged right above the toolhead so that the filament swapping process times can be much shorter. Based on feedback from Elegoo, this system is for multicolor printing and isn't intended to be used for mixing different types of filaments within the same print. From my own experience, you can mix some materials, however, they do need to be within a fairly narrow temperature range. One thing that I want to make sure I acknowledge is the situation surrounding the Elegoo Centauri Carbon 1 and multicolor 3D printing. In my review of that machine, I mentioned that I had heard absolutely nothing about multicolor printing. However, I did show in that video that on their product page, they acknowledged that multicolor printing was coming to the Elegoo Centauri Carbon in Q3 of 2025. A lot of people purchased that printer with the expectations that at some point later in the year, they were going to be able to print with multiple colors in the same print. The article I originally saw looks like it has since been updated, but Elegoo came out with a news post or a blog post stating that from their internal testing, the multicolor upgrade hadn't given them satisfactory results. Due to this, they were offering people the choice of a gift card towards their web shop, an additional year of warranty support for the Carbon 1, or a discount/voucher towards purchasing the Elegoo Centauri Carbon 2. At the time, based off of the tone as well as the options presented, it seemed like Elegoo was abandoning the multicolor upgrade for the Carbon 1, which pissed off a lot of people that had purchased these machines, rightfully so. Since then, a lot of stuff has transpired and I haven't kept up to date with it, so during my testing of this printer, I reached out to my contact at Elegoo to get some clarification on sort of where things currently stood. This was approximately a month ago, and I was told testing was near completion and they were getting ready to enter the phase of mass production. So for the sake of Elegoo, as well as everybody that purchased one of those machines based off of that promise, I really hope that they can make good on what they were originally advertising. Wrapping up on the hardware overview, at the back of the machine at the bottom, we have our power input as well as our on-off rocker switch. A little bit further up is the exhaust vent as well as the poop chute, and at the very top we have some openings where we can access screws that are used to tension the belts for the AB motors. Since I had taken the bottom panel off of the Carbon 1, I was really curious to see what the electronic situation looked like on the Carbon 2. The biggest changes I noticed is that there is a brand new mainboard powering this machine, as well as an updated board for the SSR. The new board definitely resembles the previous generation version, but they have revised some of the layout, and it looks like there's a whole bunch of different components they went with on the Carbon 2. The power supply is identical, and they are using the same belt tensioning mechanism on the bottom of the machine. You can see there is one long belt that's wrapped around the single Z stepper, as well as the 3 pulleys that are used to raise and lower the heated bed. The printer came packaged nicely, and the setup process was pretty straightforward. After removing all of the tape, foam, and protective film, the next step was to remove the 3 screws that were used to secure the heated bed to the base of the printer during shipping. The ribbon cable for the screen has plenty of slack, so it's easy to pop it into the back of the LCD, and then that just slots into place. One thing that was a little different with the Centauri Carbon 2 is that the poop chute and the nozzle scrubbing system or setup in the back of the printer doesn't actually ship inside of the machine. This gets dropped into an opening on the inside back of the printer and then secured in place with 4 screws. A bracket gets installed on the right side of the machine that you then bolt the canvas system to, and then there is a 4-to-1 filament hub that gets attached at the top of the tool head, and then 2 screws go into that, securing it in place. Finally, the 4 spool holders are installed. Each of these has its own bracket with 2 screws that goes into threads on the side of the panel, and then you just slot each of those spool holders into place. They are numbered, and it does say in the manual that you need to make sure you install them in the correct order, so that way their rewinding functionality works correctly. Then you connect one cable from the canvas system to the back of the printer, attach the 4 Bowden tubes from canvas to the top of the toolhead, and attach the lid before you are ready to power on the printer. I know it sounds like a lot of steps, but in reality, the process from getting it out of the box to first boot was probably about 30 minutes. Upon first boot, the screen will guide you through the setup process. This has you select your language as well as your region, and then optionally pair it to your local Wi-Fi network, as well as the Elegoo app, which is called Matrix. Then it runs through the initial device setup checks. This ensures that both the Hotend as well as heated bed, heaters and thermistors are working correctly, along with the fans inside of the machine, and as long as that completes successfully, it will move on to running input shaping for the toolhead, and then finally it runs a very large bed mesh. By far the longest part of the setup process is that bed mesh, because it is quite dense and it has to tap on each location multiple times. I think all in all, it probably took about 15 minutes to complete the entire mesh. The Centauri Carbon 2, like the Carbon 1, only ships with a very, very tiny coil of filament, but Elegoo did send over a couple spools of their PLA, so I started off by unboxing one, placing it onto the first spool holder, and loading it inside of the Canvas hub. One of the functions of Canvas is that it does have built-in RFID support, but at the time of testing, Elegoo didn't have those compatible spools to provide, so I wasn't able to test that functionality. Once you load Filament into the machine, you'll need to go under the Canvas menu and tell it what type of filament it is as well as its color. You can also do this from the slicer, but when loading multiple spools, I found it much easier to do it right at the printer before heading over to the computer and trying to remember what color I had loaded on which number of the lanes. Now it was finally time to print, and I started off by printing out some of the files that came pre-sliced on the printer's built-in memory. First up was the small Buddha model, and this turned out okay, but once I got it out of the machine, I noticed a little bit of sag under the chin and ears where there was some pretty steep overhangs, and then tilting the model upward, I also noticed slight areas where there was some clear under extrusion. Next, I printed out the vase model, which was not sliced in vase mode, so it took approximately 5.5 hours to print, but I was really happy with the results. The last pre-sliced file I went with was the Benchy model. This is a 4-colored Benchy, but instead of having colors designated to certain features of the boat, it just has basically filament swaps at certain layer heights. So in total, you have your initial color and then 3 filament swaps to complete the entire print. This model turned out great, and I didn't see any sort of sagging, stringing, or really any standout imperfections. From here, I was ready to slice up my own files, so I jumped over to the computer. Just like with the Carbon 1, the recommended slicer from Elegoo for the Carbon 2 is Elegoo Slicer, a fork of Orca Slicer. For anyone wondering, I did check, and the latest version of Orca Slicer does have a profile built in for the Centauri Carbon 2 if you prefer to use that slicer. I started out by printing out a ratcheting toothpaste tube squeezer. This is a relatively simple model, but I wanted to print out some of the pieces in green and others in white while trying to avoid any unnecessary filament swapping that would lead to purging. So I set the print sequence to by object instead of by layer and spaced the pieces apart on the build plate. I haven't used this mode in a while, and the last time I did, I don't remember there being a visual indicator as you click to drag parts around the build plate, showing you the size of your tool head, so that way you can ensure parts are spaced appropriately apart to prevent the tool head from crashing into a previously printed model. For anyone unfamiliar with this mode, it works by printing each object from start to finish before moving on to the next one. The Centauri Carbon printed out all the pieces without any issues, and I was really pleased with the end result. Next up, I printed out a fairly large Nintendo Switch game holder. This was designed as a single color print, but I imported it into the slicer and used the built-in painting feature to paint the Switch logo white to contrast the black print of the rest of it. I ended up throwing a brim on this model because it was a fairly large piece with 4 sharp corners, and from my experience, having a large part with completely sharp corners is a recipe for some warping. Well, the part completed without any issues, and the only thing I really noticed was that the Switch logo I had painted white had some obvious sagging, which isn't a limitation of the actual printer, but that specific logo just was sticking out a little bit too far, and the bottom had a bit of air printing where it could have benefited from just some small supports. After this, I was on the hunt for some multicolor prints so I could really test out the filament swapping capabilities of Canvas. I stumbled across a pretty epic model of a koi fish that I knew I had to print out. While for a lot of this print, the colors are sort of just stacked on top of each other in different layers, it still required around 150 filament swaps. Well, the print completed without any issues or errors in the loading and unloading sequence, and the end result is absolutely gorgeous. The last thing I wanted to check with the multicolor printing was for accuracy. So I looked for a model with defined color placement and settled on this pot planter of a Highland cow. This model had 445 color swaps and took a little bit over 20 hours to complete. As far as color placement goes, I would say that the Canvas and Centauri Carbon 2 were spot on. However, when investigating or looking at the part closer, I did see that similar to that original Buddha model, there were some obvious signs of under extrusion, primarily on some of the top layers. Also, while the supports on this model were much easier to access than that of the koi fish, they didn't come off nearly as clean as I would have liked. When doing multicolor printing with supports that are a different color than the area that they are touching and holding up, the interface area tends to look a lot messier than if you were printing in a single color print. This is just due to the contrasting colors, which make sort of those imperfected areas stand out versus blending in when they are just in the same color. At this point, I called it on the multicolor printing as I felt that the system had proved to me that it does work as intended, and in just the few models we'd printed, we had already burned through approximately 1/4 of a kilogram in purge or waste material. In a system like this, where there is only a single hot end and 4 different filaments swapping into it and going out of it during a print, it leads to a lot of additional waste. You can minimize this by printing multiples of the same model at the same time, adjusting the purge volumes in the slicer, as well as avoiding certain models that require lots and lots of filament changes. I'll occasionally use a system like this for multicolor printing if I need to, but with access to a couple of tool changers now, I find myself more so using a setup like this for the convenient spool management, as well as functionalities like continuous printing. With continuous printing, you can set the machine so that if it's printing something and runs out of filament, instead of pausing and waiting for you to then load something else, it can grab a similar filament already loaded on the machine and just continue that same print. Now I was ready to move on to different materials, so I loaded up some PETG and printed out an 8x8 grid for multi-board. I've been really unhappy with the rat's nest of cables around and underneath my desk and came across a project called Underwear that is a modular cable organization system. I watched the first layer go down for the print and noticed that there were some definite extrusion issues as well as obvious stringing. This was technically a new spool of filament, but before I loaded it onto the machine, I saw that the bag that had held it had been punctured, so I figured this is probably just an issue related to moisture. So I grabbed a different spool of PETG that I had already dried out overnight and restarted the print. This time it completed successfully and the adhesion was fantastic. This was roughly a 4-hour print and I calculated I would need 9 of them, so I rinsed and repeated the exact same print and all 9 completed without any issues. If there's interest in covering the underwear project in a separate video, let me know in the comments and I will hold off on printing out the rest of the parts and installing it until I can actually record the process. Next, I moved on to printing with ABS and ASA. About a month or 2 ago, I printed out all the parts for the Jabberwocky toolhead, which is going to be going on my Voron 2.4, and happened to see that there was a pretty big update to a lot of the printed parts. Before throwing a larger plate of parts at the machine, I started off by just printing out a small calibration print. Unfortunately, this only made it 10 minutes into the print before it warped heavily and dislodged itself from the build plate. I didn't think this was caused by a dirty plate, but just to rule out anything, I cleaned the build plate with Dawn dish soap as well as raised the profile bed temperature from 90 Celsius to 100 Celsius. I had some issues with the Carbon 1 printing ABS due to thermal drift, which led to inconsistencies in my first layer, so I printed out a large test square so that way I could really dial in the squish for the first layer. When I tried that same test print again, similar to the one I'd previously ran, after a short while it also warped and came off of the build plate. At this point I was a bit puzzled, and not wanting to lose a whole tray of parts, especially because the red is a special red I don't have a lot of, I threw on some nanopolymer adhesive as well as applied a brim before printing out the 2 trays of parts. With the adhesive and the brim, both trays completed without any issues, but I was determined to investigate the issues I ran into a little bit further. Outside of the Z offset issues, I had a great experience printing with ABS and ASA on the Carbon 1, and the only standout difference I could see or think of was that the Carbon 1 had a much smaller build chamber because they were using a flat glass panel versus the Carbon 2, which has this large lid. So I added a thermocouple to the top of the lid as well as the base of the printer so I could see what temperatures look like when I fired off an ABS print. After the heating and leveling sequence, the top lid read 40 Celsius and the bottom of the printer read 28 Celsius. Halfway through the print, or approximately 20 minutes later, the top read 48 and the bottom 33. Based on those results, I believe that the issue I ran into with warping is simply that the chamber is not getting hot enough when it's time to print an ABS or ASA part. You could work around this by preheating the chamber and letting it rise in temperature before you actually start a print, and this also feels like an excellent candidate for an internal chamber heater, similar to something like the Panda Breath that we covered just a couple weeks ago. The last filament I wanted to try was TPU. This is a filament I tested out on the Carbon 1 and had pretty good success printing out some TPU adapters for my dust extraction system for the CNC. Before doing this, I did a bit of research to see if Elegoo had provided any sort of information or recommendations on printing TPU with this printer. I did find a note at the very bottom of the product page that a special part was required to be printed to print with TPU that was available on the included USB flash drive, but I checked the flash drive multiple times and no such file was present. After doing some further digging, I found a discussion of someone else that had tried to print TPU that reached out to Elegoo about that file and was basically told that that file just didn't exist. I saw mixed feedback on printing TPU directly through the Canvas system, but since I had had relatively decent levels of success with the 85X, which uses sort of a similar multicolor feeding system, I decided I would at least give it a try. Well, the results were not good, and even with a fairly simple model that just consisted of a few cubes, there was all sorts of under extrusion. I did try a few things to combat this, like lower the retraction distance, increase the material's flow rate, and swap the filament spool to a different lane just in case there was something weird going on with lane 1, but the results were identical regardless of the changes that I made. Hey guys, deep in the editing process, but I did have a quick update. Elegoo responded to some questions I had or feedback during the review process, and they provided me with a video and file for how they are expecting people to print TPU on this machine. Unfortunately, this wasn't available during the testing process, so I wasn't able to actually confirm how well it works, but it does seem like it's at least a step in the right direction, and I wanted to make sure I included it in this video. One last thing I want to touch on is noise, as that is something that Elegoo advertises on the product page as this machine being pretty quiet. While printing with TPU, which uses the maximum fan speed, I used my phone to measure the noise from a foot away from the machine with the front door closed as well as the front door open. With the door closed and the lid on, the reading I got was right around 50 decibels with an occasional spike up to around 52. And when open, it stayed right around 64 decibels. While noise for me generally isn't a huge factor, I know that that's not the case for everyone, and it definitely is on the quieter side, and when it is idle, it is completely silent. So what are my thoughts on the Centauri Carbon 2 based on my time with it so far? Well, let's start with the good. By large, it is the refreshed version of the Centauri Carbon 1, which is a printer I felt offered a lot of capability for the price. The larger screen is nice, the upgraded cooling is definitely an improvement, and while I rarely see myself printing above 320 Celsius, if you are someone printing a lot of PPS-CF, I can see having the additional 30 Celsius being a handy feature. The multicolor swapping system canvas seems to do exactly what it's advertised, and I had no issues with it swapping out colors, loading filament, or detecting when a spool had run out of filament. I even like that there is more lighting in this printer, making it easier to peer in and see what's going on or monitor your print with the included webcam. However, one of my biggest appeals with the Carbon 1 was its ability to print with a wide range of materials, and it seems like the addition of the Canvas system has really compromised that. Having 4 Bowden tubes go from the Canvas system directly to the toolhead means that filament swaps are much quicker than having to load and unload all the way to the hub. However, it also meant that they had to get rid of the flat glass panel and introduce this bulky hat, which makes it more difficult for the chamber to reach temperature, and in my case caused unnecessary warping in my ABS and ASA printing. The addition of the automated vents sounds great on paper, but the implementation feels half-baked, especially considering there's still a large gap due to the filter, which allows air to leak out of the chamber. Honestly, unless multicolor printing and simple spool management is way at the top of your wish list, in a lot of ways I prefer the overall simplicity and performance that I got from the Carbon 1. I don't think that this new printer is a bad machine by any means, and if it wasn't following in the footsteps of the Centauri Carbon 1, a lot of these points probably wouldn't hit quite as hard. I'm sure a combination of future community mods and add-ons like the Breath will allow for further compatibility with a wider range of materials, but given the trade-offs required for this machine to print with multicolor, it just doesn't wow me the way that I wish it did. At a price point of $450 for the printer multicolor combo, I'm sure there are still plenty of people who will be attracted to this machine that primarily want to print with PLA and PETG, and I don't doubt that they will have a largely positive experience. However, if your goal is to print with higher temp materials such as ABS, ASA, or above, I would consider saving some money and instead going with the previous generation version. And that has been the Elegoo Centauri Carbon 2. I hope that you enjoyed this video and that you have a much better understanding of what this machine is, what the setup process is like, and sort of what the overall performance and capabilities are that you can expect. This was a really long review video, and looking at my past review videos, they seem to keep getting longer and longer. So I'm really curious to know in the comments whether you enjoy this very thorough A to Z review style video, which is sort of what I've always done, or if you'd prefer me to avoid covering so much of the tech specs and kind of just go into what my experience was like with the machine. It's something that I've been really curious about, so if you don't mind taking a second and letting me know, I would really appreciate the feedback. On that note, don't forget to like and subscribe for more great videos. We make a video just about every week to every other week, so there's always fresh content coming your way. And if you want to support the channel further, I'll have links in the description over to our Patreon, where there are some really awesome rewards. Huge thank you to all of our existing Patreon supporters. I appreciate each and every one of you for allowing me to come back every single week and spend more time doing what I love, which is making content for you all to enjoy. On that note, this has been Dano from ModBot. I look forward to seeing you guys in my next video. Peace, guys!